All right, this is 7.6, review for Unit 7. This is question number 8. So again, just like number 7, I have the acceleration, velocity, and position functions already written out here. Acceleration is given to you for the rectilinear whenever it's moving horizontally. That's nice, but that means the equations typically have bigger numbers in them. So again, the A of t is the 12t minus 38. Integrate that, 6t squared minus 38t plus c. Take the information they give you. 2 seconds, velocity is 5 feet per second. So you have your 2, you plug it in, right, with the 5, and then you solve, and you end up with c is 57. Replace it, integrate that equation, plug in the next piece of information that at 4 seconds the position is -2. That's what I did right here. Solve it, and you get -54, and then you replace it. All right, part B says what are the acceleration, velocity, and position of the object at 6 seconds. So again, one of the biggest mistakes I see with students is they don't know what to do with that 6. Do I set it equal to those 3 equations, or do I plug it in? And for here, you're going to plug that in. And the reason why you're going to plug it in is because you have the time given to you. So you're going to take the 6, which is seconds, and plug it into each one of those. And the reason why you're going to do that is because the 6 is your time. And since t stands for time, you're going to take it and plug it in. So you're going to take the 6 and plug it in. For the acceleration, it's pretty easy. Velocity and position might be in your best interest to just take these equations, especially the position, and plug that into y1, and then do the vars, y vars, and then do the y1 of 6. But anyway you do that, you end up with a of 6 is equal to 34. And this is feet per second squared. Make sure you have the correct units on there. V of 6 is 45 feet per second. And S of 6 is 36 feet. All right, then part C says what are the position and velocity when acceleration is equal to 0. All right, so for this one, you're going to set the acceleration equal to 0. So it's A of t equals 0. It doesn't tell you the time is 0. It says literally the acceleration is, which means equals 0. So you set that equal to 0. So that's just your 12t minus 38. You add your 38 divided by 12, and you get your time there to be 3.167. So you're going to take that time now, and if you want to know the position and velocity, you have to take 3.167, and just like we did in part B, plug it in. So it's V of 3.167 and S of 3.167. So again, if you have plugged those 2 equations into the calculator, your life is a lot easier now because now you can just go through and plug it in and solve. For the velocity, you get negative 3.167 feet per second. All right, notice it is a negative. It's okay. Velocity can be negative. When you have velocity meaning that's a negative, just means that it is, in this case, moving to the left. If it was a projectile, then it would be moving to the if it was a projectile, it would be moving down then. All right, and then notice also here the position is a negative. That's okay. Negative 0.52, that just means you're to the left of 0. Remember, when you're doing rectilinear, it's like you're on a number line going back and forth. All right, last one here, letter D, says what are the values of the displacement and distance traveled in the first 5.5 seconds. So we're going to be integrating from 0 to 5.5. That's my start to my end value there. And you always integrate your velocity. So the velocity here is going to be 6t squared minus 38t plus 57. And then you integrate that, and this is going to be for your displacement. I don't believe I said that. So displacement, again, 6t squared minus 38t plus 57. And you end up with 71.5 feet. The second part of letter D asks you to do the same thing, but this time you're going to have to find the total distance. It's still going from 0 to 5.5, right? But now we're going to put this into absolute values. So the absolute value of 6t squared minus 38t plus 57. And that is going to be 77.635